Good morning, everyone. Today's experiment will enable us to determine the chemical component of the sun's photosphere. First, we need to analyze the emission spectrum of the sun and point the absorption rays.
The black rays correspond to the absorption of chemical components. So now I've selected all the rays and determine which component it is, thanks to the wavelength. First, we see that we have two black waves here, between 390 and 400. We see that that corresponds to calcium. Then we have another one here at 410. It corresponds to hydrogen. Next, we have one between 420 and 430. It corresponds to calcium. Then we have two other ones between 430 and 440. It corresponds to iron and hydrogen. Next, we have another one between 480 and 490. It corresponds to hydrogen. Then we have two black rays just for 520. It corresponds to magnesium, and we have two. Then we have another one between 520 and 530. It's an iron. Next, we have two black rays just for 590. It corresponds to sodium. We have two. And last, we have one between 650 and 660. It corresponds to hydrogen. Oh, and sorry, we have another one between 680 and 690. And it corresponds to calcium.
So we can see that this spectrum corresponds to G type of star. The calcium rays are prominent next to the violet. So here you remember this was calcium. And we can still see some hydrogen rays. So for instance this one, or I remember another one which was here. So see, it's light but still here. And then we can see that the iron rays are stronger. So it was here next to the hydrogen here. So here you can see that it's larger than the hydrogen. And we can see also that there are some other metals that are in the spectrum, such as magnesium, which was just here, and also sodium, which was here. And then we remember that there was a hydrogen here and a calcium here. But which determine that calcium is important for the star is those ones, because it's near to the violet. So you can see that we have different type of stars, and thanks to the definition we determined that it was this one, which corresponds to those two spectrums here. So the sun is near to those two spectrums. And conclude, Here we have a diagram classification of stars, and we can see that J stars are here. So we have just to go up, 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 and since the sun is our reference, we see the 1 here, and we have a cross here. So we can see that our star is in the principal sequence of the diagram, and you can see that it's at its middle of life. So first, when you burning star, you have just a blue emission, so you're just born, and then you start your life and keep going like that, and here, and then you can become a supernova or black hole.